Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the pH of a buffer solution of a weak acid and also the conjugate base of that weak acid contained in a salt using the Henderson-Hasselbalch equation. For this problem, you're asked to use the Henderson-Hasselbalch equation to calculate the pH of a buffer solution that is 0.30 molar ascorbic acid and 0.25 molar potassium ascorbate. The Henderson-Hasselbalch equation tells you that pH is equal to pKa plus the log of the concentration of the base divided by the concentration of the acid. In this case, our acid is ascorbic acid, and our base is the conjugate base of ascorbic acid, which is the ascorbate anion. And this anion is added to solution when the potassium ascorbate dissolves. And when it dissolves, it dissociates to give this potassium cation plus the ascorbate anion. And you know both of those concentrations because you're given those concentrations as part of the problem. One thing you need to find is the pKa, and once you have that value, you can solve for the pH. You know that the Ka for ascorbic acid is equal to 8.0 times 10 to the negative 5, and that's at 25 degrees Celsius. You look that up in a table of acid dissociation constants, so we're assuming all of this is occurring at 25 degrees Celsius. You can find the pKa using this relationship. pKa is equal to negative log of the Ka. So if you substitute 8.0 times 10 to the negative 5 into this equation for Ka, you'll find that the pKa is equal to 4.10. Now you know the pKa, so you can go back to the Henderson-Hasselbalch equation and say that pH equals pKa, which is 4.10. You just solve for that, plus the log of the concentration of the base, which is the same as the concentration of potassium ascorbate, because you have 1 mole of potassium ascorbate dissociating in solution to give you 1 mole of potassium cation plus 1 mole of ascorbate anion. So if you have 0.25 molar potassium ascorbate, you also have 0.25 molar ascorbate anion. And you know that the concentration of your acid, which is ascorbic acid in this case, is 0.30. So all you have to do then is do the math, and you'll find that the pH is equal to 4.02. That's what you were asked to solve for, and you've done it, so you're finished.